This is the largest submarine ever built in the world, the Typhoon Class. It measures 76 feet wide, 38 feet tall, and 574 feet long. Here's a person's size for comparison. With its massive 48,000 tons of weight, this submarine is roughly 34,500 cars heavy. These submarines are equipped with the ability to fire nuclear warheads underwater. Armed with armaments capable of destroying an entire continent, these submarine cruisers rise to the status of the most potent weapons. A symbol of Cold War apprehensions and a banner of Soviet Navy might. We are delving into the myth of nuclear leviathans today. The 160-person crew of the Typhoon Class submarine can live in comfortable quarters. In typical circumstances, it can remain submerged for 120 days, and possibly longer if needed. These are the two primary long-pressure hulls of the multi-hull Typhoon Class submarine. There are 5 inner hulls total. The crew work area is divided into 20 compartments, with 10 compartments for each pressure hole. Parts of the turbine room, kitchen, bathroom, gym, and reactor compartment of equipment and every other kind of living space. The torpedo hull is this. With automatic torpedo launching units, this compartment functioned as a torpedo handling area. This room is used for control. The equipment for steering, diving, servicing, and other submerged operations is located in this compartment, which serves as the submarine's brain. This compartment contains a number of notable stations. The maximum submerged time allowed for by design is 3 months. You are all aware that there is no oxygen beneath the surface, but how do over 100 people are kept alive underwater by submarines? Let us examine how oxygen can be produced on a submarine. There are 2 methods for producing oxygen. Electrolysis is the first one. An automated electrolytic oxygen generator, or AEOG, is this device that produces oxygen. Both positive and negative electrodes are present in this device. Potassium hydroxide is added and these electrodes are submerged in purified seawater. After that, the water is separated by applying electricity to these electrodes into the gases oxygen and hydrogen. Hydrogen is released from the negative electrode and oxygen is released from the positive electrode. These pressurized tanks are then filled with these gases, oxygen and hydrogen. Through pipes and air vents, the breathable oxygen is distributed throughout the pressure hulls. The second way to create oxygen is to burn chlorid candles. These systems produce more than 4,000 liters of oxygen every hour, which is then released overboard. The oxygen is released periodically throughout the day at specific time intervals. This candle is made of chlorid. The generator is a chemical oxygen cylinder. It is composed of a combination of 2 primary ingredients, sodium chlorate and iron powder. The heat produced by burning the iron releases oxygen from the sodium chlorate due to the reaction of iron oxide with heat. This is a backup plan that they can utilize in the unlikely event that they lose power and are unable to obtain electricity or another external power source. Despite its tiny size, the solid oxygen candle has a huge capacity to produce oxygen. This is utilized in spacecraft as well. Nuclear energy powers the propulsion system of a Typhoon. A few submarines are powered by diesel-electric systems. The range of this diesel submarine is limited to 14,000 nautical miles before refueling is required. A week of non-stop operation at 200,000 horsepower for each type of submarine would require 5 million liters of diesel fuel for the diesel engine and only 4 kilograms of enriched uranium for the nuclear submarine. Not need to be refueled when one of them takes a service call. More than 30 years worth of uranium fuel will be available when it is put into service. 2 pressurized water reactors are installed on the Typhoon Class submarine. Let's take a look at how these nuclear reactors operate. This reactor vessel houses the fuel assembly tubes. The fuel is derived from nature, plutonium. The radioactive element uranium can be found in seawater and most rocks, where its concentrations range from 2 to 4 parts per million. That is formed into tiny pellets, sealed within metal tubes, and then fused together to create a fuel bundle. A fuel assembly is typically made up of more than 200 of these rods bundled together. Inside the reactor core, uranium atoms fission is the first step in the energy production process. A neutron striking an atom of uranium causes it to split into two, releasing 2 or 3 more neutrons in the process. Fission releases a tremendous amount of energy and frequently results in the production of gamma photons. Neutrons like these can split apart or maintain a chain reaction that generates a lot of heat inside these fuel tubes by using fissile nuclei. By simply coming into contact with the hot, high-pressure water, these tubes subsequently transfer heat to the primary circuit water. The heated water subsequently flows to a steam generator via pipes and pumps inside the steam generator. The hot water is then transferred to secondary water in the steam generator by way of a bundle of about 6,000 inverted U-shaped tubes. When the water in the steam generator reaches a boiling point, it transforms into steam. There are 3 coolant pumps and 3 steam generators in this reactor. This steam is continuously run through the pumping process and arrives at the turbine that rotates the turbines. The propeller receives power from the massive gearbox that is turned by the rotating turbine. A vast array of offensive and defensive weaponry is carried by nuclear submarines. There are 20 RSM-52 intercontinental ballistic missiles that make up the main weapon system. The main hulls are separated by the 2 rows of missile launch tubes. 1 kilometer can be destroyed by the 100 kilotons of nuclear warheads that are contained in each missile. Ballistic missiles could be fired from the submarine while submerged, but since the rocket engine requires air to burn, it cannot function underwater. Okay, so tell me how they fire missiles underwater. A seal that stops water from pouring into the launch tube is the key. 2 compressed air tanks are part of the weapon system when the missile hatch opens. A burst of compressed air is fired to the bottom of the missile launcher to initiate the launch. Once the missile is forced out of the tube by the air forces, it then bursts the seal at a speed of about 49 miles per hour. It can cut through nearly 40 meters of water with its sufficient momentum. Its rocket engines can ignite once it is in the air. These missiles have a maximum range of 12,000 kilometers. Seeing the Typhoon Class submarine in action is truly amazing. With Russia aiming to deploy multiple oxygen generation sources, nuclear warheads, and contemporary amenities like a gym, it is a shining example of modern warfare technology accomplishment. Build 2 more submarines of the Typhoon class by 2026 at the latest. Seeing the most recent advancements in technology for national defense should be interesting.